So how's everyone doing? Good conference? Awesome. So this is really a fun topic for me. About 2.5 years ago, I had the opportunity to go to Boston to the RISC-V dev room. And I was, there were so many challenges that were going on with running Linux on RISC-V at that time. And I was not exactly in a confident state about when I could really start building robust IoT systems on RISC-V, all right? But over the last 2.5 years, I have seen so much progress. If it's contributions by Sci-Fi, if it's contributions by the open embedded community or by the Yocto community, you name it, they just all came together and it is just hopping. It is running well, all right? So what I get to talk to you about today is some fun stuff about running IoT apps on embedded Linux on RISC-V. So what do? I work in the IoT service team at Amazon Web Services. I'm a technologist. I go around, talk to people, say how cool stuff is. Super fun, super awesome to do. I actually am the maintainer for the Meta AWS project, which is how customers build, install, and run AWS device software on embedded Linux. And if you didn't know, AWS is also a platinum sponsor of Yocto project and a platinum sponsor of automotive grade Linux. All right, so a lot of great work has been going on in that area. But why am I talking about open hardware and open software together? Well, if this was 10 years ago, I mean, open hardware was just really a dream, right? Open software has been around for a while. I don't have to explain to you, oh, everyone gets to contribute, everyone gets to inspect code. It's so awesome. It is totally awesome. And that's how the community was able to grow so big and so fast. But open hardware is the new thing. We're democratizing hardware today. And it starts from the silicon up. That's what's so exciting about it, is because now we're not at the, I would say, we're not forced to take silicon and eat it. If you want to create your own core, if you want to create your own processors today, you can design those and you can get them fabricated yourself. Nothing is stopping you. So it's really a super great time to be in this technology today. But let's talk about IoT, all right? So with IoT, there's always the idea, this is where you get all the makers and the dreamers and so forth about creating IoT devices. When you see things like Hackster.io, that is what you're seeing there, an idea and prototype. But I've seen so many times that it's challenging for customers and makers to do that pivot from that prototype, from that idea to production, because really it's a really huge space to wrap your hands around. And the earlier that you learn about what you need to do to be successful in IoT and run millions of devices out there, the easier it's going to be for you to create those devices with that mindset on the outset to get these devices out there. So we're going to go through, we're going to deeper dive down into the provisioning and the running of the device. Not so much on the building and the manufacturing and so forth. That'll be for other talks. When we're talking about commissioning, that's the network connectivity. I'm not going to talk about that today because I'm just connected to Ethernet. I'm going to show a few demos, live demos today. Let's hope that they work. But I'm not going to actually talk about commissioning, which means connecting to your Wi-Fi access point, connecting to cellular, connecting to NB-IoT, connecting to whatever. None of those radio things, where you actually have your cell phone connected to the SSID. All that kind of stuff. I'm not going to talk about commissioning and decommissioning today. But what I am going to talk about is provisioning, which is how do I get these credentials onto the IoT device to seamlessly connect to the cloud? How do I get that process started? Because a lot of times when you're prototyping at the beginning, when you're doing TLS 1.2, you're taking a key and you're taking a cert and you're copying it to the device and you're like, awesome, it works. But that's not how you're going to go to production. So we need to talk about provisioning and how we actually provision at scale. We have to get that sorted. And the next thing is, what's the greatest way that we can go and do telematics? How can I detect if I have security challenges on my machine, on my IoT device? How can I tell, or actually I want to reverse that a little bit. How can I remotely configure my device? And I'm going to show you exactly how you can do that today. So let's go ahead and get started with building. That's building embedded Linux. So how many people in the audience have actually done a bit-baked build, open embedded, Yocto? Okay, so 1.5. So I'm going to start from the beginning. This is not Debian. This is not Ubuntu. This is not SUSE. This is not Red Hat. This is where you define exactly, explicitly what you want on that device and how you want it to run. So this is the evaluation board for today. I have it all connected up here. I'm actually going to show that demo live. This is an earlier Sci-Fi board. It's called the Unleashed. It has 4 cores. People tried to run a full desktop system on this board. It's really not powerful enough for that. They have a new board that came out that's good for that. But this board is great for IoT. Okay. So that's the one I'm going to use today. Now let's talk about initialization. This is a lot of gobbledygook, right? So first thing is I need to get all the sources that I'm going to use to tell the build system how to make my embedded Linux. Now, when you see that repo tool, how many people have heard of the repo tool? That's very popular, started off in Android. It's actually a lot more people in the Yocto community are using it. If you use the repo tool and works against an XML file, lists all the repos that you need to source down, down at that time, all the sources that you need to build the embedded Linux system. What you're actually bringing down onto your computer is a set of instructions that will help you build the sources to make your embedded Linux system. It's a custom distribution. So you're going to have these recipes brought down to your system that are organized into concepts called layers. You put them all together in your configuration. You put, these are the packages that I want in my embedded Linux system. All right. So I do the repo sync. Down there, can everyone see that? Okay, it's a little bit small. I didn't want it to be that small on the screen. So that's bringing down all those recipes. Then this instruction here sets up all your environment variables on how you're going to run bitbake, which is the compilation system. It's like Gmake, but it's called bitbake. And it actually started off in Gentoo like 20 years ago or something. But it's matured a lot since then. And it's actually run by the Open Embedded board. So I have a script down here at the bottom. Very, very dangerous, I guess, if you want to run that. I don't suggest just willy-nilly take scripts off the net and then pipe them to bash. But if you know what the script is, you can go ahead and do that, I guess. So you have all this stuff. You have these recipes, right? They're going to tell the system how to build your embedded Linux image. But what about your stuff? You have an app too. You're going to build an app that's going to do what you want it to do with the IoT. You're going to talk to an MQTT server, send some messages, maybe get some instructions back, do some local actuation. So you're going to have your own app. And you're also going to have a set of your own configuration that tells bitbake how you want your distribution to work. You get to say if you want Vim on the system or not. You get to say if you want DHT. It's not like you get all these packages on your system like you get on an Ubuntu or something like that, and you just have to suck it up. In this system, you tell exactly what you want. It starts off with creating your application layer. And of course, bitbake or Open Embedded has a script that helps you create your own custom layer. And then you get one demo recipe. So what you'll see at the end of this talk is the layer that I built for this demo. And you'll be able to take that as a template as well, if you, of course, like what you hear in this talk. Okay, so when I created my distro, the first thing is I don't want to blank password, right? So I made it so that the distribution had a non-default password. What's wrong with that? That's right. So if you want to get more fancy, you get like some of these routers where you'll see every single router has a different password. You want to do something a little bit more fancy, but at least I don't have any fancy. Other than that, I have a set of tools, very basic tools, I2C, SPI tools, control modules, very basic stuff. I don't have a bunch of user applications here, do I? I don't have Vim, I don't have Nano, I don't have Emacs. And the reason is that this is a headless IoT device. It's not like a Raspberry Pi where it also functions as a desktop. I'm not going to want users to log into this device and start editing files. It's a headless, self-sufficient device. So I configure my distro. This file is actually in conf/distro, okay, within the application layer itself. So after you do that, then you can actually add your layers to the bit-bake build. So some important layers here. The first important layer is Meta RISC-V. That's actually a BSP layer that expresses to the build system what a RISC-V system looks like. I'm not going to get any more detailed than that because that's a whole other thing. But then there's another one here, Meta Sci-Fi. That's another BSP layer that comes from Sci-Fi. That gives me the instructions to actually run the code on this device proper that I have up here. There's a couple of more layers that are important. Of course, there's Meta Play and Meta SW Update, which is for system update. But Meta AWS is the bit-bake layer that I maintain. And that has the AWS Cloud device software on it that I use. And then the last one here, which is the application layer that we're building today. Okay, so once I do that, then I'm actually going to do a build, right? So the build invocation up there that's read it with me, distro equals, that's the custom distribution that I just built in my custom layer that I just told you about. Machine is the machine definition for the board. That tells the system all the things like how's memory structured and what drivers are going to be included and all that kind of stuff. Just for the board, just for the chip to function. And then it invokes the date with a target. Remember that target, RISC-V IoT distro. What's going to do is it's going to look at that target and then build everything in all of its dependencies going all the way back. So bit-bake is super, super good at understanding the entire dependency matrix, organizing it properly, and building everything in order. And actually, just recently, we did a lot of great work in reproducibility as well. So it's a super, super strong dependency management and build system. Then what's it going to output? It's going to output a set of files. You can get a compressed rootfs. In this particular case, I'm using a WIC file. A WIC file organizes all the partitions for me. I'm really simplifying it. Just for those who know what a WIC is, just bear with me. But if I have multiple partitions in my system, like a boot partition and a rootfs partition, I need to organize those with sizes and what those mount points are. And that's what the WIC structure does for me. And then I just flash that to an SD card. First build time on this machine is about 90 minutes. Now, if you're building for x86 and ARM, it can be shorter than that. But the difference with RISC-V and those other targets that I just talked about is uninated. They have uninative packages for those other architectures that allows you to download pre-built host tools. Because there's no uninative package available for RISC-V, you have to build all those host tools yourself. So that's going to take a bit longer. Okay. All right. So now we're down to the IoT part. I'm going to just pause for a second. Anyone have any questions about what I just said here? A lot of information for those who are not used to open embedded Linux. That's any questions? Okay, we're doing good on time, so I'm thinking that we're going to be fine for demos. I'm pretty happy. So, adding the IoT to your district. So the first question that you need to ask yourself is, what exact features do you want? So that's why AWS built this piece of software called the AWS IoT device client. This is like a huge menu, a matrix, a mashup of all the different IoT features, What's good about this too is it actually takes no one is going to log into the IoT device and start running program. That's exactly what we're doing here. It's all automatic. So some features that we're going to be looking at today, if you can see this, it's kind of small. I know the screen is kind of small. We will be doing fleet provisioning today. We will be doing device defender. We won't be doing jobs. All right, I'm going to add it. I'm going to show you how to add it to the build, but this is how you do system updates. We're just not going to have enough time to do that in this talk. All right, but I'll show you how to do it, and I'll show you some things to watch out for. So when you get to that point, and actually, if you think about the WIC file that I just talked about with the different partitions, when I get to that point, think back to the WIC file and how you would have to take care of your WIC file with a separate position, partitions for system update. And you'll see that closer to the end of the talk. So now what I need to do is add my custom application. I'm going to treat device client like this. AWS IoT device client has its own recipe in the meta AWS layer. I'm going to treat it like its own thing. Because eventually, when you go to build your IoT apps through embedded Linux, this is what you're going to have to do. You're going to have to create your own custom recipe to instruct the build system on how to build, that's compile, and install your app to the root file system so it can run when you boot the system. So what do I need to do? I just need to add one line to what I showed you before in the baseline distro configuration. Only one line. That's the recipe that I just added for my custom application. All right. Everything else is the same. Very easy. If I go back here, what am I doing here? Well, I depend on AWS IoT device client, which is the recipe for the device client in the meta AWS layer that I just talked to you about. So I depend on that. BitBake says, oh, dang, I'm going to install, I need to install this too, because I depend, which is runtime depend on that particular application. So it's going to build that application as well, put it on the root file system, and it will be invoked, okay, at boot time. But I have to do all these other things as well. Today, you're going to look at fleet provisioning, and you have to install things like provisioning key and certificate. This is one of the many ways that you can provision. It's a simple way. It's not always the best way, depending on your use case. It's only an example, all right? So I'm using fleet provisioning by claim, so I need to add a bunch of cert. I need to add cert, I need to add a key, and I need to add the root steer, which in TLS 1.2 is needed to verify the endpoint that I'm connecting to. That's when I'm using MQTT with TLS 1.2. and I talked about that, you just add one thing. So I have a cert, I have a key, and I have the root CA. I'm connecting to something. There's a few different ways actually that you can, what's funny? There's a few different ways that you can connect the IoT port, right? The most common way is using TLS 1.2 mutual authentication, right? So I'm not going to go through all these one by one and for you. I'm really, really itching to get to the demo because I'm already half done with time. So we need to prepare for fleet provisioning. That key insert that I'm putting on my device, that's only for provisioning. When I first connect to the cloud, I'm going to say, hey, I have this key, I have this cert. Can you please give to me the real key and certificate that I'm going to use to start messaging with the cloud? So that way I can provision those keys automatically. Now, why would I want to do that? If it's only one device, if I'm making only one device, I don't care. I can just manually copy the key. But if I'm going to build this image once, and I'm going to use it to image 1 million devices, I need to have a secondary provisioning mechanism. Because I cannot give each device a unique private key, which is the device identity and the certificate, if I'm only building one image, right? So I need to have this provisioning mechanism. Before you do that, you need to think ahead. Remember, that's the basis of this talk. How are you going to do that prototype to production quickly? You need to think ahead. Thinking ahead is, how am I going to manage my system? The mechanism for managing the system, which we'll get to, is the system update, right? And over-the-air updates. To do that at scale in AWS IoT, we do something called fleet indexing. To do fleet indexing, you need to have a thing type and a thing group attached to your thing object that represents your device. So you can just think of this as a bunch of metadata that helps you search for things, all right? But I need that up front because every device is going to be unique. Every device that connects to the cloud is going to get its own identity. But I need to have this metadata attached to it. That's the first thing I need to do. We have a provisioning template. I'll show you that in a little bit. We'll create the claim artifact. All right. Well, those are already created for the demo, actually. And we're going to build the image. So why don't we go ahead and do that now? All right. First of all, what I'm going to do, because did not. So this is the distro configuration that I talked about. Can everyone see that, or should I maximize? Okay, so I have all of these things. So what I want to just do first is I just want to do fleet provisioning. So what I'm editing right now is some configuration that tells BitBake the features I want to add or remove to the AWS IoT device client. So the only thing that I want to have right now is fleet provisioning, okay? Okay, so I edited that file, fine. The next thing I want to do is that I want to start the build, right? I want to build my image. What is it going to do? It's not going to build the whole thing that takes 90 minutes. It's going to do a delta. It's still going to take a little bit of time. The compilation itself does not take long, but to build the root file system and build the WIC image can take some time. So I might have to come back to this depending where I am in the slide deck. But if I just look here, I have it in my history, and I can just invoke this command line. And that's going to start building my image. And this is exactly what you're going to see when you start building your own image. You can see device client, RISC-V IoT distro, that's our target. Now it's building the root FS, and that's going to take a little while. And I'm going to come back to this in a minute, all right? So we're building the image. This is exactly what I just did in the distro file, right? So the distro file, from a system configuration perspective, says exactly what you want to add. For those who have already used Yocto Project or Open Embedded, this is actually the same as editing your local.conf file or your auto.conf file underneath the build/conf directory. Except instead of doing it in something that's ephemeral, because local.conf is not put into source control, I'm doing it in a way that's more permanent by making it a distro file. So now we're at the demo, and it's still building the WIC. And while this is happening, I am going to bring up this. And that is definitely not the view you want to see. So I should have done this before the talk started. Oops. Can't see what I'm doing. Did I not plug it in? Of course I didn't. Okay, let me turn the exposure up well. So this is the board. And I'm just going to pop out this SD card, and you can't see it well because I didn't focus. And just move this a little bit. Now I'm just going to pop this in to my SD card burner, and you can see that the build finished, right? Here we go. So now what I want to do is I want to put this to dev SDA. Now, if I didn't know that I needed it to go there, I would usually run ls block to make sure that I'm writing to it, but I'm pretty sure that that's the one. So, so let's go ahead and let that run. Now, another thing that you're going to, when you start building this image, if you're using the Meta Sci5 layer, the default WIC file is about 8 GB. That's way too big for an IoT device, right? Actually, I could, right now, I have 2 partitions that are a gig each, and I could probably have that. You always want to keep the flash reduced to reduce your costs for your device. So this should finish up in just another minute, and then we get to see if it actually provisions, because what I have over here is IoT Core. How many people have used Amazon Web Services? Few. And IoT Core? All right. Did I see a hand? Oh, okay. All right, good. So what we're going to do is we're going to run this fleet provisioning template. And this fleet provisioning template tells the system, if I get a request to provision a certificate, I want all this stuff run. I want a thing created, an IoT thing created, and it's going to use this prefix, right? It's going to add these properties to my thing attributes. It's going to say that I want to be in the consumer gateway thing group, and I also want to have this thing type, which happens to be the same name as my machine definition, all right? Now, that's all done. That's good. And what's going to happen here is it's going to provision this device, given the network and everything is all good. And you'll see that, well, I have more than 50,000 certificates in here because I was doing some testing. But this certificate right here at the top, that GUID, that is the certificate that represents the certificate for fleet provisioning. And when this machine boots headlessly, what's going to happen, if the network works, is that there's going to be a new thing created here with that prefix. So why don't we just go ahead and pull this out, just to make sure that it actually did finish. Okay. And just so there's no smoke and mirrors, you get to see me actually putting this in, because I love live demos. And what I'm going to do next is I'm going to turn this on. And then what I'm going to do is I'm going to connect over serial. And now what's happening is that the system is booting. Now, every once in a great while, what the flash is going to do is that something gets wonky with the flash and the rootfs won't, or it can't even load the kernel, right? So then I have to flash it again. Happens like 1 out of every 10 times. Probably less. So now it's booting the system. The network looks good. I can actually do bind, okay? The network should actually automatically come up, get a DHCP address, all that kind of stuff. All right, so I have a boot prompt now. That is the operating system that we just built and imaged onto that SD card. Now what I'm going to do is come back over here. Let's see if we provisioned automatically. And we did. We got our new thing. So that means we provisioned a certificate. We have a policy, which is an authorizing factor. It tells IoT Core exactly what this device can do. And now I can connect. All right. So if I just go ahead and log in here, I'll have an IP address. Amazing. So awesome. And if I do, sometimes this messes up, but if I do a status on AWS IoT device client, then it's running automatically. All this is available, like you just say AWS IoT device client recipe in the meta AWS layer, and it just works, right? Of course, you should create your own recipe that has all the additional configuration in there for you. But you just saw totally works. So now what I'm going to do is move on to the next section. But to save a little bit of time, what I'm going to do is give you a little bit of a preview here. I'm going to move back over here. I'm just going to turn this off. And I'm going to go back and run my trusty Emacs. And I'm just going to flip down here. And I'm going to start the system build now while I'm talking, just to save some time, because we only have like 15 minutes left. Just too short. So what we're going to do is do a little pub sub example, okay? We're going to just add the ability to do pub sub, which is publishing to the cloud some messages, being able to subscribe to a topic, getting information back. I'm actually going to add another cool feature down here too, which is for device shadow, which is for command and control of the system. So I will go ahead and add that. And then what I'm going to do is add device shadow configuration. And what device shadow configuration is going to allow you to do is tweak the configuration of the device client that's on the edge and from the cloud, from the device shadow in the cloud, okay? So I'm just gonna go ahead and save that off and start that build again, and we'll continue talking. We'll let that build while I go. All right. So when I connect to the cloud to publish and subscribe in device shadow, I'm going through a thing called device gateway using that TLS 1.2 authentication that I just talked about. All right. There's a lot of features in there. I'm sorry, I won't have the time to talk about it today. Now, when we pub and sub to the cloud, when you're building your IoT device, you're going to send messages, but you're going to do something interesting with that data. So once it comes in through the message broker, you actually have routing that you can configure within the system to send the data to other services in the AWS cloud. I'm not going to get into that today. We're just going to see a message come into the cloud automatically from the device client today to give you an idea of what you can do. So I already added the samples and the pub sub. And we'll go back here and we'll see how we're doing with this build. And it's still building the root FS. So why don't I just go back a little bit more and I'll go through a point that's important. Now, there's different classifications of IoT devices. There's times when you want to send a message and you really don't care if it makes it like 9 out of 10 times, or 9 out of 10 times. It could be that the message gets stopped every once in a while. If you have a situation like that, you want to use something that's a bit more cheap on the messaging side, which is Quad 0, which is effectively the fire and forget configuration. A quality of service zero. amount of time and you want to receive that message or resend that message, that's quality of service 1. So that's just another thing that you want to keep in mind when you're configuring your IoT application. All right, so we're almost done here, hopefully, with the WIC image. And I'm just going to pop the SD card out of here. Now, what I'm also going to do while we're waiting for this to finish up is I'm going to get back over here and flip down to test and go here. And I have this DC pub topic. Now, if everything works fine, what's going to happen is that you're going to see a message coming here at the bottom that says, hello world. Amazing, huh? You're probably, when you build your IoT device, I'm sure it's going to be a lot more exciting than that. Well, I hope so. And what is also going to happen? It shouldn't be any surprise. I'm burning a new image, right? So what's going to happen? Again, it's going to be fleet provisioning again. Why is it? Because the certain key that was on the image before I flash it is gone. Bye-bye, disappear. Because I'm reflashing the SD card. So this is done, and why don't we just go ahead and flash this guy? Now, while that's going, what I do want to turn to also is all the source code that I'm running, IoT device client. This is something that you want to go and tinker with, right? And to learn about IoT functionality with AWS Cloud, this is using C++. So how many C developers in the house? Oh, okay. I thought it would be much more than that. But that C and C++ are the, I would say, the most common programming languages for IoT today for embedded devices. So this is all C++. What I showed you before, the code, the code for fleet provisioning is right here under source fleet provisioning. So if you want to see all the code that it took to actually do that fleet provisioning demo, like the underlying code, you can go and check this out. And the same for what I'm about to show you here, which is the pub sub sample. So now this is done, and I'm just going to pop my SD card out again. Let's go back to cheese. Let's get this in. Let's turn you on. Let's go back here, reconnect to serial. Here we go, dun, dun, dun. Now, if everything works, we know that fleet provisioning works, right? Does everyone trust that fleet provisioning works? All right, so now let's see if the pub sub automatically works. Now this, it depends sometimes on timing, but I'm hoping that it will just automatically work. So we should see a message come through here, down at the bottom. And if it doesn't, it's still booting, okay. Nothing? Oh no, what'd I do? Always has to happen, right? That's right. Yeah, let's see what's going on. What'd I do? Okay, that's awful. I don't know what just happened. Okay, I'm not going to spend a lot of time on this because I want you to see other stuff, but I am totally surprised on this. Let me see. Okay. Okay. So somehow the system D didn't pick up that. Okay, so why don't we move on? So because we're going to try to flash again, I only have 5 minutes remaining and only half the presentation done, which is kind of sad. So I'm going to just go through this really quickly and not show the demo because I only have 5 minutes remaining. So another point that you want to look forward to when you're doing your IoT devices is device security. There's two kinds of security. One is something that can be audited, and which is like static configuration. And the other that is where you have to pick up metrics at runtime to detect all these challenges that you see up here. So there are stages in order to do this, right? You can set up you have to set up the audit configuration. You need to set up the metrics, at what thresholds you're going to set alarms on, and so forth. Unfortunately, I don't have all the time to do that today to walk you through that, but I want to give you some foresight into what you want to configure when you're doing your IoT device. You want to keep security in mind. When you think about the type of checks that you want to do, it's stuff like private keys that are shared. It's a best practice to ensure that every single device has a representative identity, which is usually the private key. Most times it's within a secure enclave or other kind of security construct, like a puff or something like that. All right. The other thing is my device behaving poorly? This even has a little bit, it's not just rules, but also there's some ML capability built into Device Defender that you'll want to check out. All you have to do, now the audit check is done on the cloud side, but the device side metrics has to be enabled inside Device Client using the DD feature. Now, I'm not going to do that right now because I'm almost out of time, but if you're really, really interested in it, after the talk, I can actually show it to you, okay? And then finally, provisioning. This is a wild diagram. I actually showed this at Embedded World earlier this year in the class that I gave. How do I use the cloud to do CI/CD, the AWS cloud? We actually have a repo called meta-aws-ci, which gives you all the stuff that you need to actually build Linux distributions in the AWS cloud. What's important about that is when you do system update, you want to be able to distribute update images globally. So you can use services like S3 and CloudFront to have global points of presence to do your IoT device updates. System update, I cannot say strongly enough, or over-the-air updates you probably heard about before. You really need to take care of that at the get-go. You need, well, not do everything, but keep it in mind. Don't back yourself into a corner is what I'm saying. All right, just get the constructs in. You don't have to get all the CI/CD stuff in at the get-go, but get system update built in front, because the one thing that you really want to get implemented when you build out your Flash, and you'll see this in the WIC file that's in the distro that I wrote, where the WIC file has two banks defined. This is called A/B updating, okay? Where on the get-go, you'll actually flash to the first bank. That is what you're booting off of. That is what U-boot is targeting. When you do system update, like I like SW update talks to U-boot and says, I'm doing a system update. I just laid down a new flash on bank 1. And now what I want to do is change the boot pointer from the 0 bank to the 1 bank. And I want you to boot the 1 bank. But that's after verifying stuff like the signature on the image, okay? So a lot of details in there, but what I can say is you use AWS IoT jobs to facilitate that. You stage the SWU file, which is the system update file, up in the cloud, download the image onto your device, and then update it with the -i flagging. You can drive that all with AWS IoT jobs. Okay, so I'm out of time. Please go visit the Meta AWS repo. The Meta AWS repo is where we have all of our recipes for device software. There's more coming. We're continuously building that out. And there's pointers there to Meta AWS demos and also Meta AWS CI. And also check out the IoT device client. Now, what I will be adding on probably the demos repo is the pointer to this private repo that I talked about today. Now, some things for the future, because what I showed was really basic and I only was able to show half the demos. What I want to add is this thing called fleet provisioning by trusted user. I don't like the idea of putting a private key and a certificate manually on image. Not good, right? You do that as a quick thing. It's one step above manually provisioning certs and keys, right? So, but it's not really a great thing to do. So what you want to do is when you're provisioning devices out in the field, do it by trusted user using Cognito or something like that, a cell phone, and then provisioning your certain key to the device with that additional layer of authentication. We're going to have more distributions. And next, I really like this Unleash board. Unfortunately, it has been deprecated, the board that I showed you today. It's really, really hard to get. I would suggest there's another RISC-V board out there I really like. It's from Microchip. Used to be Microsemi. They have the PolarFire SoC board. I like that. I just ordered the new Unmatched board. That's really for a desktop. And there's a few others out there that you can pick up. And with that, thank you so much.